Всем привет. Спасибо, что пришли на наш доклад.
Hello everyone, welcome. My name is Alexei. This is my colleague Ilyas. We are from BI Zone. And today we'll talk about automating forensics and how you can develop a universal multi-purpose tool to deal with forensic artifacts. To begin with, a few words about ourselves. We are from a SOC. I'm a principal SOC analyst. I do various types of automations and R&D projects. Ilyas investigates and responds to incidents as a third-line analyst. And he's also dealing with automation of forensic artifacts processing. Okay, here are the things we are going to talk about. Number one, we'll talk about forensic artifacts. We'll talk about forensic artifacts and where they stem from and why we need them. Then we will try to develop a kind of a pipeline for processing artifacts, and then we'll try to give it some practical spin to see how it all works in real life. A caution. The presentation has a lot of artifact words in it. Ilyas, the floor is yours. Hello everyone, my name is Ilyas. Let us try to find ourselves in the shoes of a SOC analyst live, expert, and we'll see what they face almost daily. Well, number one, the analyst might be missing some data the CM has, and the first type of a situation is like that. The host is outside of scope. Like the antivirus software detects some host suspicious activity. We try to understand what kind of host it is, and we have no information from this host because it is not covered by our monitoring, and it is in a segment which is not subject to monitoring. An example of a case like that can be Mimikatza detect in a host, and we try to understand what it is, and we have no data. It means that we need to find more data from the host and ask for it. Another example can be like that. An investigation, or let's put it this way, we see some internal IP connection which looks suspicious, but we don't have any information on this IP, so we ask the customer what it is, and we see that this is a balancer. And it has something external behind it. Okay, the balancer is not a source in our system. It means that we need to find out the logging or the logs. Another situation, well, we can have some telemetry from a host, but it can be not enough. For instance, we detect some suspicious service established with a host, but what kind of service it is, what's the context for it? Say the audit is not properly set, and we don't have the 4688 event, so we don't know what happened around. And the most painful case, when the attacker is making steps throughout the customer's architecture, And so we face the first cases, then other cases. There are no logs from some hosts, so we don't know anything. And from other events, well, from others, we don't have enough events. In all these cases, we need to obtain data. And for this, we just gather artifacts from the host. Okay, what is an artifact? An artifact is an entity which might have some information, a digital trace on what was going on. They can have various types of information, like the launch of processes or utilities, the file information, and or creation of files or network connections. The artifacts can come from a file system or from memory. They can be binary and as a text. Text as logs, and binary, you can have a look here. If you deal with binary artifacts, to analyze them, we usually need to parse the artifact. Here you can find all possible sources of artifacts, some endpoints, and usually this would be some server's information used by the system to optimize its performance, or logs from hosts. And you can also have network artifacts like traffic and also logs. And another domain is cloud, which is quite new to us. And it has both the network artifacts and the endpoint artifacts, and also the hypervisor logs having information on what was going on. Here we are considering some artifacts from endpoints. They can split into categories, and when we run incident investigations, the key artifacts are usually so-called execution artifacts. The artifacts have information on the launch of utilities, when they were launched, the files handled. It can be in Windows mcache and user assist, and from other systems you can see, for instance, bash history. And a very good category of artifacts is the file system artifacts, like MFT. It has information on the time when the file was created, modified, last accessed, and so on. Some other good artifacts for an investigation are browser history information, so this includes network connections, and the history of the browser has specific links the user used. Here you can see a typical workflow, how a SOC analyst receives and processes data. So they start with a request, they send it to the customer collects artifacts, sends them back, they are processed, and then they have results as a filled-in ticket. There are some nuances to the process. If the customer has an EDR installed, in this case, the analyst can ask the customer for a permit to get an artifact. So they get the approve and they go through the EDR server to obtain the artifact on their own.
Здесь мы рассмотрим способы.
Okay, how do we collect artifacts? There are two approaches here. Classic forensics. You take disk images and memory dumps. It usually takes days to analyze. There are many things to analyze there. And an analyst would have to investigate all this in detail and have a detailed report on this. And there are also SOC forensics. So this is a quick artifact collection to quickly understand what was going on. So we only gather things we need, or we gather some basic sets. We analyze them. The data analysis takes half an hour to a few hours from one host. And then we receive incident tickets filled in. Okay. Artifacts from one host take half an hour to a few hours to analyze, depending on what was going on and whether it was fed into these artifacts and what kind of artifacts were collected. So if we only have logs, they are quick to look at. If we have the whole assembly of artifacts, then it takes longer. So we analyze multiple hosts. This takes even longer. This will be hours at least. And to build the timeline, so we can take days. Even if we have some pinpoint analysis of specific artifacts. So in this case, time is against us because while we are analyzing this stuff, the threat agent can make progress in the infrastructure or encrypt the infrastructure. And then the artifact analysis will not help us. Okay, we need to help the SOC analyst process this as quickly as possible. We should understand that the SOC analyst has a number of clients, and apart from analyzing artifacts, they should also do their routine work, have a look at the CM and other drop-offs. We recently received this new service called Compromise Assessment. So the customer comes to us, say anyone, and they want the infrastructure checked to see whether they have compromised hosts and so on. In this case, they usually don't use EDR or other monitoring tools because this is one-time gathering telemetrics and artifacts and other things from the scope provided by the customer. And the scope can have dozens of thousands of hosts. So manual analysis is not there. So we need to automate the process. Well, we can highlight the compromised hosts for deeper analysis. Okay, we have a lot of problems and they have to be solved. And there are some ways to do it. You can use some standard tools or toolkits, or you can develop bespoke forensic virtual machines. And to process a lot of artifacts, you can hire a lot of analysts and to let them work through it. Okay, but we will do it differently. For the toolset, the standard toolset doesn't work here, and criteria are different, like the processing speed. For instance, if you take Plasa, if you apply it to all artifacts, a lot of time will be needed for processing. That's why we decided to build our own toolset using open source utilities. And we don't want to use a virtual machine, which is heavy. So we want this toolset to be in the container to analyze all the artifacts in the container. And we also have a scaling issue. How to process dozens and hundreds of artifacts from various hosts simultaneously. So this is just one part of our toolkit. Going back to the SOC analyst rules. So they have correlation of events analysis tools, and they also have expertise accumulated throughout the years, and this includes the detection and correlation rules. So we just bring it all together. To begin with, let us try to design the processing pipeline to make us happy. So we have the input, the artifacts. They can have different formats, like binaries, texts, or databases. So we need to get it, to process it, and to send it to the CM and some other storage to store them in the raw format. So if necessary, an analyst should be able to have a look at them. Okay, what we got as a result looks like the ideal process: extract, transform, and load. ETL. Okay, this is a universal process primarily used to process big data. It has the extract stage, when you extract data from a storage, then you transform data, validate it, and filter it. You have some business logic behind this. And then you load all this to a storage. Then the data will be good for further processing and analyzing in some third-party systems. Scaling is an issue. How to scale properly to process dozens and thousands of artifacts? We started with two ways. Number one host, one instance for artifact processing. The second one is to load artifacts in batches and to process them in batches. Well, batches has a nuance. If you process one artifact for, well, quite long, so if one artifact stops the pipeline, then the other ones in the batch won't be processed either. Okay, where do we take the artifacts from? There are several sources. We start with the incident response platform, where we have tickets, and we have some comments and files there. Artifacts can also come to us through some secure channels. You can go to the file share, and if the client has the EDR server installed, we can use it for collecting artifacts. There are also web portals. So this is an independent source where the analyst can manually load an archive or specific artifacts to follow the pipeline. And then you can unzip it. Okay, transformation and parsing. The artifact can come to the pipeline in various formats, and it's important to understand it here. Binaries or just plain text can be not good enough for processing at the next stages. So you need some pre-processing. It'll be used to transform the data into a readable format, and then it goes to some unified structure. So here's an example from a journal. So then you need to normalize data and to filter it so that we don't have noise in the data. Another issue is these artifacts can be missing information about the host and operation system or any other context. This is really important for processing manually or using some correlation rules. That's why we enrich the artifact, so every entry of the process artifact, so we enrich it with other fields so that the analyst shouldn't look for the hosts in the CMs, the operating system, and so on and so forth. And then we have a kind of a unified structure. In this case, we have picked JSON, it's universal, and it can be converted into other formats if necessary. Loading artifacts to the storage. Apart from CMs, we can have some other sources. You can look at logs without any correlation. And there we can also focus on local storage permits so that you launch the pipeline in the machine. So if we save data in the local storage, okay, that's clear, but then another question arises: how to deliver all the data to the external sources. For this, we use a message broker to receive the messages and to send them further. Okay, some ideal example, ideal conveyor. Here you can have some issues. When we started practical implementation, we have the brainstorm stage. We came up with some options. We tried to use some ready utilities, but then we decided that our own utility would be more useful. Another option was to further develop some open source options. Okay, the infrastructure service was a really important thing. So we deployed the service in Kubernetes, and to process the data as an executor of the scripts, we selected Apache Airflow, which, if necessary, can run pods, and there you have parsers, and there you can load artifacts, and they can be stored either in the external storage or to CM through Kafka. A few words about the structure of the pod. We have various sources which can send us artifacts. We have the web loader where we can put the artifact. So pipeline is launched automatically with other sources, but with web we just send the artifacts to S3, and the Airflow sometimes runs pods using the S3 sensor to see whether there is an artifact following a given route. A few words about the S3 storage structure. We are not using any database. We decided to try to use some identifiers of important parameters. So a route or a way to give an artifact. There are 3 stages here: loading the artifact, processing, and the final. So you have the customer, the artifact name as an input, then the pipeline moves the data to the process folder. The data is further processed by the pipeline, and the output is moved to the data folder. A few words about the pipeline at different stages. So you can see the level of script Airflow, the function or task, and also the logical level is shown here in more detail. So the artifact can be done through S3 or the pod. The data is moved from one folder to another folder, then the parsing process is launched, the normalization, the filtering, and all of that is sent to the S3 storage. Okay, now some details on the parsing stage. Okay, let's see how all this is processed. All of this is packed in a container. The input is an artifact. It can be an archive with logs or a set of artifacts from the whole system. When you launch the container, then the dispatcher is controlling this. It calls the unpacker. The unpacker tries to understand the type of artifact, and based on that, unpack it. Following unpacking, we understand which parser is needed, and then this parser is focused on this, and then we have sometimes normalized data following the parser, or sometimes we need to normalize the data. This depends on the case, whether we are using our own script or open source scripts. If they're open source ones, so we need to modify them for our data model, and then we have JSON as output, which is further fed into Elastic.
Well, that's almost all about the parsers. There's a part of the parsers that we have covered, and in essence, there are many more of them, and it works very well. This is how actually it looks like at the entry point. This is event 4635 from the Windows security log, and we would get only the margins that we would need for the detection of post-analysis. And then we would enrich that. This is how it's been enriched with events. On that slide you can see an example of we would get from the prefetch. Not all the margins have been filled, not all the fields are there, and first they would be enriched with our service information in order to understand what kind of an event it is. And then the parsed information would be added, the enriched information based on the data about the IP, and we can get that from register and from some specific files or from the utilities conclusions. This is how the normalized event looks like. It was put together, so it means that we have the same margins that we got from the prefetch, and we added some service information, and we enriched that with the data about the system. And all in all, we get quite a regular event, and we can work with that, by the way. One of the ways of that system, and there was a requirement that all these scripts, sparsing and filtration, should be launched locally and in a Docker. Parsers packed in a Docker image and pushed to the Docker registry, and it can be run locally or on our infrastructure. Now a few words about the statistics. So we run that system using artifacts, and we added dozens and single units, and processing time of one archive with artifacts may take from 2 to 30 minutes. Most of the problems would be caused by such big artifacts as MFT or UATX logs, which may contain a lot of data. And this is because of these big artifacts. The pace of processing may go down. We may launch up to 30 different archives, which can be processed simultaneously. And we would get from 1,000 to 500,000 events as an output. Let's speak about the problems we run into. First of all, this is about processing corrupted forensic artifacts. Not all the artifacts actually are intact when we get them, and they may be corrupted from the very outset. And if the question is open, what to do with corrupted artifacts, then resource consumption when processing large artifacts. In case of some structured data, there is no problem, but in case of binary data, for instance MFT, we have to upload that into the memory and process it out there. There is a problem with launching all that in a Docker. There was a problem of unified time field to store the data about the timeline. We are using different fields which would reflect the essence of this or that tag. But for some artifacts, there is a problem of making that in the same timeline. And an expected problem is when we actually are uploading one single artifact, a log, for instance, and it's very difficult to enrich that with the data, and the context would be lost. That's the end of the theory and, for instance, pipeline looks like that. So there are 3 scripts. The initial codes are IPT, and after processing the pipeline, we would get tick messenger with a link to the processed artifacts. Now, a few words about MFT. This is what we managed to detect. This is what we got at the end of the day when it all started working. That's an example of events from MFT, and it's been enriched with our correlation rule. So we are detecting the pooch. This is ls dump in temporaries. Then we detected the open and cache, and we get the path. In some cases, that would be a tag, whether it was executed or non-executed, and sometimes the path would help us in investigating the event. And also, there is a path to the malicious utility. That's an example of a case based on after-runs utility. From that, we would get all the persistence provided by this utility, and what is very convenient, it would actually provide us with the hash files. And again, a suspicious path. Some executable Windows file, we look at its hash, and we put that into the VirusTotal, and we'll see that this is something malicious. That's an example of a prefetch. A prefetch has very interesting fields in the sense what files were used when launch. When the process is being launched, it is using certain files, so that's a list of these files. Here you see a hunting example, for instance, a malicious utility, Duelco in the temp stamp. Next, one of the most interesting artifacts in that context is IMCache, because it has a lot of very useful fields and margins from PA header and hashtags. In that case, for instance, we enriched the fields, and we detected that this is a TeamViewer utility, but the name is changed. So these are malicious services. Nothing special. And we get a script from the log, and also the correlation rule was applied to that. Also, we are parsing such an artifact as a consort host history. That's a history of PowerShell commands. And also we can detect a malicious utility. Then we analyzed a case that an alarm was sounded when certain file was downloaded from a suspicious path. We started looking around, and we saw that persist was left there on the left-hand side, on the right-hand side. These are the fields that we got from Chrome. And also we unparsed the authorization logs, and we could see that there was a hack. In essence, there are 400 plus events that ended with logon success. So probably there was a fruitfuls taking place. As a result, it all worked well, and still we have to improve a lot of things, to fix a lot of things. The assumption that we made when we designed it proved to be right, and it means that we now have to improve that all and build into our process. Thank you so much. Thank you for your attention. Good afternoon, dear colleagues. Thank you so much for your presentation. Tell me, one of the main problems about what you have described is about collecting the artifacts from the host. Do I understand it correctly? That these containers were launched on a host. You are collecting necessary artifacts. Then it would be correlated, somehow enriched, and afterwards you will get a verdict. Right. It depends on the context of the launch. If we do that locally, then it would be put up together. Or actually it could be collected different way. Well, I think that the question was about collecting RAT from the host on the side of the customer. Now, we are getting artifacts from the client and we are using our infrastructure in order to process that. It depends on the situation, how it's all structured. And we have a utility to collect the data. We render that to the customer, and the customer was used yet in order to collect the artifacts. Is it the problem of the customer to collect the artifacts, or you offer certain tools in order to distribute the tools and to make an analysis? Actually, we did not speak about that in our presentation. It all would depend on the infrastructure of the customer. Right now, we are providing the customer with the utility, and if the customer needs a consultation, certainly we will help him. Well, do understand what detention policy is being used, and whether it all depends on, well, actually, how to plan for the disk space. We have not counted the exact figures, but when we did the designing, I made some assumptions. If we look at the whole list of artifacts from Windows host, then one host would require 1 gigabyte. One host would require 1 gigabyte. This would be parsed, normalized events, and the archive itself would take some space as well. Thank you so much for your presentation. There is a question. How do you check that the number of raw data matches the one of processed data? Any mechanisms of checks and verifications? Do you keep any statistics? If you lose something in the process, or if there is a kind of a mistake. It was mentioned on the slide, so what we do? Now we introducing IDs on the checked data, and we send that to the message broker. If we fail to do that, then we could see that judging by the number of the event. In addition to that, we have that diagnostics conclusions made by firewall, but we have not yet learned how to collect statistics. So it means that probably you can miss some data. If some error occurs, again, it would be shown in the very full conclusions, and the errors would be seen in the analytics if something goes wrong. I have a couple of questions, as far as I understand it. Your main transport is transferring the ready-made archive from the customer. But did you consider that the data artifacts may be transferred real-time from customer to you and back? And the second question is, you said that you can process simultaneously about 30 archives, one code per each archive. But you say that you may process many more. Are there any limits to your solution or not yet? Will you take the second question? As for the first question, it was about... Well, at the moment, we are processing what our customer is rendering to us. As for the live data is concerned, collecting that from the customer, we have not considered that option yet. Well, it depends on the resources provided to us by the engineers. But really, it could be scaled up. It would depend on how much has been dedicated to Kubernetes. I have two questions. What about security? Security in terms of data transfer. How can you transfer sensitive data, logs, and banking data safely and securely? Gigabytes of hosts, so that's more than enough. Well, look, we have our standardized channels of data transferring, something which is being integrated with our portal. Also, we have secure channels of a messenger and our shared channels. Speaking about the banking secrecy and other confidential sensitive data, and so we have not worked yet with anything like that. So this is not real-time analysis. It means that the client would collect some log and he would parse that and would come up with a verdict. Real-time analysis is possible only on the basis of EDR. And actually, we do that outside EDR. And the second question. You speak about correlation, but you have not named that. So what about the correlation of the events? Do we have a real correlation between the events when you can compare a network connection or something being uploaded on the host, etc., so that you can come up with a conclusion that there was something malicious? We looked at that in the context of the correlation rules, that we have our own rules database, and it would work on the basis of ELK. And we made in an ELK bus. And then actually it would be processed on the side of ELK. Thank you so much. Thank you so much for your presentation. Is your system capable of telling what artifacts were created by the client and what were created by the malicious actors? what artifacts were created by the client's system and what artifacts were created by the criminals in order to hide their activity, malicious activity. Well, we look at the artifacts that were collected from the operating system. What a malicious guy collected could be noticed later on, if certainly we do not have any monitoring systems on the host. And if anything interesting is there, we can collect that separately and analyze that separately. I wonder how legal it is to automate the processes. Will it be difficult to render that data to the court? Can you take that to the court in order to prove the legitimacy of this data? Legality of that data. This is not our task to analyze everything and to render that in legal terms. We just analyze big data and we show where to go deeper. So it means that we get an image of a disk and analyze that. We just identify the potentially compromised hosts. This is our objective. Thank you. Thank you for the presentation. I have the following question. There is Logon Tracer, which visualizes an event from Windows logs. Do you plan to do anything like that in your solution? We plan to use the available visualization tools, such as what? Well, we have not considered that question yet, so we'd like to integrate into what is available now without some extra services that would have to be supported, maintained, updated, etc. Thank you so much. We ran out of questions, I think. Thank you. I liked the question about the marking of events. Data collection from the whole infrastructure. So it goes to you then.